Welcome to the Group 24 presentation for detecting and predicting bradycardia. So this is the data set for one of the patients which has, this is the timestamp, this is the columns for heart rate variations for that particular timestamp. The second and third tasks were actually denoising and cleaning the data, which is already done by the RP detection algorithm given by the TA. Now after this, the fourth task was to make the use of RP detection algorithm. This is done by this way, which will give us index and peaks. Now the fifth part was to get the heart rate from the detected peaks. So we have to calculate the amount of peaks in that, but in any particular minute. So every row will have, every second will have 128 rows, and for every this has to be done for 60 seconds, and this will give us the count of all the peaks that are given in that 1 minute. And then after that minute, we'll reinitialize every variable and we'll append it to a row length variable. So after this is done, we'll actually use one of the file called compute task, which will actually make our task helpful to calculate the graph for heart rate for every minute for every patient. So this is for the fourth, second, third, and this is for the first one. As we can see, only the first one has bradycardia, and none of those has bradycardia except then the first one. Now the seventh and eighth tasks were basically to develop the signal processing algorithm and manually annotating that task. So what we'll do is we'll actually check if the value of that at that particular minute is less than 60, then we'll assign it bradycardia, and if it is greater than 60, then we'll not assign it bradycardia. And this is our algorithm and the annotation part. Now the ninth task was to evaluate the performance of the bradycardia detection algorithm in terms of false positive and false negative. So we go to the Android code where we have actually written the functions for false positive and false negative. This is how it is happening. What we are doing is we are taking an average of the 3 consecutive minutes and using that value to calculate the false positives and false negatives throughout for that particular minute. And then what we do, we can show you that the Android code is a pretty clean UI which has the drop down for all the patients. We go to the first patient, let's say we go to the first patient and we say press detect. It will tell you that the bradycardia is detected, as we saw in the graph, because only that was the only patient that had bradycardia, which has all the false positive, false negative, 2 positive, 2 negatives, and also the elapsed time. That is one of the tasks. Then we go to patient 2, we say detect, and we see that the bradycardia is not detected for that, and we have all the parameters as well with the elapsed time. So now after this is all this is done, we like to show you that the machine learning algorithms that we have implemented. The first one is logistic regression, second is SVM, third is KNN, and then it's K-means. So what we have done is we'll go to the MATLAB code right now to show you how the SVM and logistic regression is done. So what we have done is we have used the fit SVM function of MATLAB to train a model called SVM model, and the SVM model gives us weight vector and the bias SVM vectors, which are actually ported to the Android code with the test samples to get the values of all the predicted values. So along with that, we are also using the same GLM fit for logistic regression, and we are getting something called Z. That Z is again transported along with for every test sample, and it is transported in a CSV file to the Android code again. So and for the KNN and K-means, this is done in the Android from scratch. So let's go to KNN first. KNN is a basic prediction algorithm with K is equal to 3, as we have taken over here, to give us the right values of all the value of the prediction. And now we go to K-means. K-means is a bigger algorithm with expectation maximization, where we have firstly assigned random centroids, then we have made clusters, then we have made centroids, then again the same thing again and again until convergence, and the value of K over here is 2. We have used 2 clusters because that's what was necessary. Now we go ahead and see for the logistic regression, and we predict for patient 2. If you press predict, it says that logistic regression bradycardia is not predicted, and it also the elapsed time. And along with that, we have SVM. If you go ahead and select SVM and predict, it also says the same thing with lesser elapsed time in this case. Now we go to patient 1, let's say, and we check for KNN, and for KNN it gives us a value of again, as we saw that bradycardia was predicted in patient 1, so it will predict it again for us. Now if we go and check for k-means, I guess it will do the same thing for us. Yes, it does. So this is, and as you can see that elapsed time has increased significantly because the convergence part, and same goes for SVM and all of the. Let's do for one patient 3 as well, and we predict and predict result, right? So this is how it is happening throughout the application. And moreover, this all has been imported and ported to Android. That was the 16 task, so we have completed 16 tasks, the 80% of the completion. Now when it comes to contribution, everyone apart from the first 2 tasks which are already done in the RP algorithm, we think that everyone has equally contributed. Vivek and Pravachan were actually the key factors in making the Android code work, and me and Amok were the basic people who were actually doing all the MATLAB code from scratch. We interested the data, we made charts, and we also implemented the machine learning algorithms which are then ported to Android. So thank you.